Hi everyone. So today we're gonna talk about. Let's write it down here. Last time, if you remember, I ran the code on Unix on Ubuntu, but I didn't run it on the online compiler. So today, first thing we're gonna do is run it on an online compiler, run the previous program on online compiler. 2, we're gonna go quick review over the data types, especially the bool. I didn't explain it good. We're gonna talk about typecasting, casting, or what they call sometimes type convergence. Converting to between integer, character, and so on, between the different data types, and float. For example, integer to float, float to integer. And there's two types of that. We have the implicit implicit typecasting, and we have the explicit. The implicit, we don't need anything for it. We can do it quickly from our definitions and variables. In the explicit, there's two ways. There's the function notation one and the C way, and I'll do both of them. What else are we gonna do? We're gonna run a program on that, or a program on casting and converting integers to float to integer, and character also. And how can I type a character as with its hexadecimal value, decimal value, binary value? We're gonna also take a program on what happens. Remember, we took the short data type. What if we enter a number out of range, meaning that short can't hold it? Short holds 2 bytes. What if I enter a number that's greater than 2 bytes? What will happen? We're gonna see that a program on that. Program on oversized, let's say oversized variables. So let's get started with this. First, let's learn the previous program. I don't know if you all guys remember the previous program we did in lecture 2. You can go and check it in lecture 2. You'll find lecture 2 in the description of this video. I also added the code, this one, in the comment section of lecture 2. They didn't like it in the description section, so I added it in the comment section. And here we can see this is run. Let's do clear. No, not here. Clear here. If you see, this is also Unix Linux based. Remember what I was doing commands on my laptop here. Let's check this command. Without doing compile here and execute here, you can do it with the commands line. So now I'm doing compile, and I'll execute it by using main. And here is the result. You can see it gave us the same result. Here are our data type. I have unsigned integer. That's one of my data type. Unsigned only takes positive numbers, and my variable is, this is the variable, unsigned integer number, that I named it that way. And here we have a short data type, snum I gave it an initial value of 10. I named my variable as. And what's a variable? To define a variable is a location or a name storage that we can manipulate. We name it in a memory and we use it. So snum is a name of a memory location that has a value of 10, and we draw this memory in the previous lecture. We have short, integer, long. All of those are integer, and we saw the differences between them. It's only 2 bytes, 4 bytes, 8 bytes is the size. So the range of numbers will differ. This is the max and min for short. This is the max and min for integers, and this is the max and min for long. Float and double, we said they're the same. We use them to represent decimal points. 10.5, for example, 10.23473. This is the decimal point or radix point. Then we have characters, which are letters. I defined it. And characters, be careful. We always use what? Single quotes for characters. We're gonna take strings, but we have to include the string libraries. Strings we put in double quotes. And I think this covers all. And we have the bool. Bool, I'm gonna cover it today in this lecture. So let's see. Remember, variables are named storage. A named storage that we can access and manipulate. Okay. This, and I'm gonna remember to print the addresses today over. So let's take this out. I'm not gonna need it anymore. This is okay. Let's go over it real quick. This is the size of unsigned short. We put the size of. This is a function that takes what? Unsigned integer, and it will give me. And this was supposed to be integer, but I changed it. And this will give me here what? 4 bytes. An unsigned integer is 4 bytes. A short, size of short, is 2 bytes. And here how to print the minimum max values. We use unsigned integer max, short max, short min. This doesn't have a min, the min because it's the negative value. This the min value for unsigned integer is 0. It goes from 0 to this number. And here we go from negative 32,000 to this number, positive 32,000. We have integer max. We need with those, we need to use what? The libraries. Remember to include the libraries. We had the library of climits. You can use climits by itself, or you can use limits.h by itself. We can use cfloat, and floats are for what? For the max and min for a float. And we did it in this part over here. Float max and float min. We can do the double the same thing. And we also have, remember, long double or double double. Those, they're bigger in size. So now let's go to our. Okay, I don't need this. Okay, we'll come back to it to run a program. We're gonna run our program here, and on I don't have Visual Studio. The only thing you do, where you copy the code and put it in the Visual Studio as regular, as you do compile it by doing build, and then run it by doing start without debugging, and it should work. Maybe some will give you some issues, some functions, but everything until now will work. I'll let you know if something is not working. Okay, we're gonna talk about casting, and let's open a gedit, and I think it was gaith.cpp. Okay, it's opened here because I had another one open and I didn't. So here's how any C++ program should look like. Yours, when you start, you always start with this. And remember, don't go to the long way, go the short way by analyzing what you have. Here, what do I have? Here you put your name. This is documentation. Comments /*. This is for multi-line comments. I started with /* star and I end it with star \. Multi-line comment, single line comments use what? /, 2 /. You usually put the date. Let's put the date. And a description of your program. Here we're gonna do typecasting, let's say, or what they call type conversion. And let's see. Okay, typecasting. Let's say we have an integer. Let's do it as num. And let's say I have a float. And let's give it an initial value. What's the harm in that? Oh, float num. Do it as float num. And give it an initial value of 10. Remember, what's num and float num? They're variables, or what we say, memory, location, storage that we can manipulate and access. So now we have integer num, we have garbage in it. It declared 4 bytes in memory, and there's some data in it, previous data, but we don't care about it. But we can allocate anything. For a float, we'll have 10.5 in it. We'll have 4 bytes that has 10.5, and we showed this last time. So now, what are variables? If you know, those are reserved words: integer, float, include, IOStream using. Those we can't use as a variable. We can't declare it as a variable. We have some rules for variables. It what? Rules for this. Rules for variables. And num is a variable. Integer is a data type. And this we can say an identifier or declaration. Must start with what? Either a letter or character or underscore. Underscore, which is this. It must start with either one of those. It can't start with a number. I can't say 1 num, but I can say num1. It can contain. It must start with a letter or underscore, and can contain letters and what they say, digits or numbers, underscore, but it can't contain any special characters, meaning question mark, and sign, mod, all those. It can't contain any of those. So let's make it look good. Okay, I declared a float. Let's declare a character and see what happens. A character is 1 letter, and we said we'll put it in single quotes. And let's do my letter and end every C++ statement with a semicolon. So I have 3 variables. This is gonna take a total of 9 bytes in memory, for the integer, 4 for the float, and 1 for the character. Here, remember we said those are cins and friendly couts. Here I can say cout, or C is case sensitive, be careful. So I can say cout, enter an integer, and I'm gonna enter the integer in whatever you type. Cin is anything coming from the keyboard. I'm gonna put it in num, which is my integer, and now I can see out. It's good to have end lines so your code looks good, your output looks good. Here I can say cout. I want to replace whatever is in float. I gave it an initial value here I didn't give it, but I want to override that value. So here I can say enter a float. And I'll do cin. Where am I gonna name location? What's the memory location? Save it in num, and cout end line. And should I take a character? No, the character I'm not gonna change it, but I'm gonna cast it in a minute. So here I run it. Let's do a cout and say the casted float equals, and I'm gonna cast the float first, meaning convert it to an integer, and I can do that by saving that float and let's declare integer x equals f num. Save it as an integer and now print it. Print x and do end line. Now if I say cout, it won't change the fnum value, but it's taking a copy from what's in fnum. If I didn't have the cin here, it will be the 10.5 and putting it in an integer x. This will take the decimal part off, so it's print 10. But we're gonna see in a minute what's gonna happen. Now let's say the casted integer, and we want to put it in a float. So I'll declare here. I can't put it before I give my cins because I want to change the value here. So I'm changing the value here. I'll say integer float casted number. Let's put it as, and that's what I'm gonna output here. Casted num, and I'll do end line semicolon. Okay, so let's run this real quick and then I'll come back to the others. Save, and let's see here. Let's do G++, which is this G++ compiler, and I can say my file is gaith.cpp. compile that one, it no errors, and I'll say a.out. Enter an integer. Let's put 16. Did I cast it? Enter a float. What am I gonna put for a float? I'm gonna change the 10.5. I'm gonna change it to this. Did you see how did it cast the float? And the casted integer gave me 0. I think I didn't say equal. I didn't put cnum. I know my error now. Okay, let's check it. Here I didn't say equals what? Num. I should have named it implicit and explicit casting, but okay, I'll name the next explicit casting. So now let's go back to the code, compile, run, and let's put 1991 and 14.567 1491. It didn't change anything on what? The integer part, it just gave the same thing, and for the float part it took what? The decimal part. Why? I changed this whole number to a float, to an integer. Let's go and see the code again. And now this is the implicit casting, where we do it by, and I changed the 14.675. I input it here. I changed it to an integer here. I saved it in an integer, whatever is here. So if this had 10.5, I'm taking 10.5 and saving it in an integer. An integer only takes 2 or 4 bytes here, but it doesn't take the decimal point. Why did it print as 0 a while ago? Because cnum wasn't initialized. It didn't have any value. Some compilers will give you garbage from whatever is in the memory location. Now let's do the explicit casting. Okay, this should have came. I did my cns, and let's do the algorithm. Let's consider this as the algorithm. Okay, home. Now we're gonna do the explicit casting, and we said there's 2 ways where we use the functional notation, and I can say, for example, what did I declare as a float? Let's use here cnum again. So I can say, I'm gonna change, okay, I want to cast it to an integer, fnum to an integer. So I can say x equals f, or what we say, integer f num. Convert the fnum into an integer and save it into x. This is functional notation. No, this is this is C-like casting. The functional notation where I pass it as a parameter to the function. And I'll do cout, and this is, let's do this, C like notation. I can say equals, and let's put fnum, my float, equals this fnum as integer, and here I'll do the same thing. I'll say cout, and we said this is the functional notation, and fnum as integer, equals this, and here I can do end line, make your output look good, and here do an end line. I know I'm used to put end line and semicolon, so now let's do the float casting. Float to integer, and here what did I declare as a float? See now, but I took it as a changed it. What did we change it to? So what I'll do here is, in case, I'll change the value of fnum. It's taking the value, so I did convert it to fnum. Now I need to cast an integer, which is x, so that doesn't make a problem. Cast the float, x. I want to change fnum here. I don't want it to take this integer value that it was 14. That's why I was thinking. So I'll put fnum again back to equals 10.5, and let's leave those. It's okay. I'll put the fnum as 10.5, and now I casted the float to an integer. Now I need to cast an integer to a float, and let's take both ways. Oh, what happened? It didn't copy. Let's take them both. Let's take those two lines. Why did I do that before? Copy, and select notation, and we're gonna say here, I'm gonna convert. Do you want? We can use either num or x, the value we just cast it to a float. But let's put it as x. That okay? I'm taking this as x. Let's put, oh, this in CNUM, yeah. I'm gonna put it in a float, and I say float, and here I'll do a float. I'm gonna do it for fnum or what? I'm gonna do it for x, and here I'll do CNUM, and I'll float cast to x, functional notation and the C-like notation. So this should work. What I would like to do is print here the fnum to show us what that number was before we cast it. So here I'm gonna do fnum. Okay, this is, and here I'm gonna do the same thing. And here I need to see like x as float. It's good we came back for this. This as a float, and here I'm gonna have x, and let's put an x small letter, looks better, equals, and let's close it, and let's print X before it's changed to C num. Okay, there's another thing. Let's see if the code this. I don't. Is it gonna work? Is this gonna work? Is it gonna print X? It should. But let's see what happens. Honestly, this is the first time I do it like that. I'll put it in a line before it. I'll put the equation in a line before, and here I'll say print X. That's the way I do it. But this came. I'm gonna try it anyway. It's good to always try new stuff. So this is okay. This is good. Now I save. Now I'm gonna compile it. Okay, invalid error of type integer and unresolved type. Let's go and see. Two binary operator. Let's go see line 30. What we have. See what didn't it like? See how it is good. I'm thinking is what I was saying. Let's cast this before and print here what? X. Hopefully this will work. I'll put the equation for it. And let's do the same thing for this X. Control copy, and what I'll do is Control V. What's up, Daddy? I'm working, Daddy. 1 minute, Daddy. Let me pause this. Okay, guys, I'm back. I fixed this while, so I put each one of them on a separate line. This is the C-like casting, and this is the function casting. I'm casting a float fnum to an integer. Here I'm casting an integer into a float, C-like casting, and this is functional notation casting. An integer or a float. No, this is an integer X. I'm casting it to a float. Saving it in a fnum. And here I wanted to show you something. Let's say we entered here a num, and I'm gonna show you this thing. What if we said here C out and num, and what if we entered a floating point in the input? Let's see what happens to it. So this is gonna print it and line, and I want to print also the address of that value in memory to show you the memory location. So the address of num equals, and let's say this address, this is the address sign, that and sign. Okay, oh sorry, didn't take it. So, and I'll do and sign, and this should be printed to the and I want it to look better. I'm gonna do this, close it here, add this, close it here, and I'm gonna print here what the num, so it will tell me the address of this number. This, remember, couts are really useful. They're good to making your code look really nice and your output more user friendly. So this should be good now. Address and memory, remember, and I want to add the same thing here, and let's see what the num will be at the end. Just put it here, just testing, and save, and let's go and compile and run, and let's put here 25, and we said we're gonna put a float. Let's see what happens. The address of num25 is, this is the address in memory, but what happened? I have the E notation. It shouldn't give me this way. Enter a float. Did it take anything here? No, it didn't. The casted float equals 0. That value is 25. So this gave me what we call a, some compiler will give you a runtime error. Runtime error are errors that happen during runtimes. We have compile time errors when we compile the code, as we saw previously. So let's compile this again, but I'm not gonna input or the compilation was good, so all I need to do is run it. That's true, so I'll put here 25 instead of this, and this is the address it gave me. I'm not sure if this E means, no, E, this is hexadecimal. Okay, this address is in hexadecimal, and let's put here 0.875, enter. The casted float equals 12, the casted integer, and remember those were the implicit casting, we did them, and we can see the code. Let me put the code here beside this. It's really good. That's a good idea. Come on, come on, come on, come on. No, don't do that. Here we go. This is the code. That's a good idea. Here I have cout and enter an integer. Here it is. I entered an integer, num, enter, it took the, and I have an end line. I have two enters. That's why it's giving me two new lines, one after the cn and one here. Cout the address of num, the address of num25, number 25, which I had it here. Num is 25 there, well, I inputted here this 25. Out the address, this is the address sign, address of num brings the address in memory. This is the address where it's saved in memory. Now enter a float. I entered a float which is 12 points. It took it and saved it in fnum variable, end line, two end lines, because I had a one on the cn, the enter, and this one. Now my algorithm here cout the casted float. What did I do here? X, I did implicit casting. I just saved what? Fnum, a float, in an integer. Here I saved an integer in a float. It didn't change anything here. So now I use the explicit casting, where one of them is the C-like notation, and we had fnum as integer equals x. So fnum, which is 10.5, as integer equals 10. Functional notation, same thing, fnum, which is 10. Let's try and we outputted x. I want to show you fnum. So you know we didn't change it in the memory location. Cout fnum should stay the same, 10.5. Only I just wanna only print that one. And here I can say just checking. And always good thing to add end line. Let's go and clear. Now I need to compile it again because I changed something in the code. Run it and let's put 13. Here's the address of 13, 14. Where did I print? What? I didn't take this one? I didn't save, yeah? I was surprised. Here you go, main fnum was not declared. Okay, we need to put didn't save again. I'm used to Ubuntu. I'm not used to get to edit, but I'm liking it now that you can have the code. Usually I open two terminals and I fix the errors on one side, and let's do this 16 and here see like notation fnum as integer equals 10. Just checking. Okay, 10.5. It came back to 10.5. And now what are we doing here? We're doing the function notation casting, and now here we're casting an integer into a float. Okay, and integer x equals 10. I took that value from fnum 0.5 and I casted it to 10. And now in the last one here we did I printed the address of 16. It stayed the same, it doesn't change the address. And we did both casting, so we finished by this casting. Casting is really good, useful sometimes too. Now okay, we want to use the string one, the character casting. And should I use this? No, let's write a new code. And I should have copied Gaith, but no problem. Let's close this and let's do git edit and C or character casting. Let's name it. Printing it as an integer and hexa. That's why I did a new file for it. .cpp. And let's write quickly the code. I should have a IO stream. I didn't add the documentation here. No problem. std, and now we have integer main, body of my function, return 0 and close main. Okay, first thing I need to declare a character. How do I declare a character? I say char data type and I name my variable as ch. We can give it an initial value of I'm always gonna use my letter G. Now for doing the this casting, the character casting, here we can do the same thing, the implicit and explicit, where we, what did we do there? Let's see, we set integer x and I want to cast what equals, I'm casting a character into an integer. So say I can do this casting character and I'm gonna do C out the character CH casted to an integer equals, and what is it gonna equal? Is gonna equal X, and I'm gonna do end line, and I need the same copy to do that was, let's see if it works first. Might not work because we need the library, but the library we need it. Okay, the library I need it for the binary, so no problem here. I can say here, let's give it a new value in case I don't want to use the same values. If one of them is not changing, I can say character and use the function integer casted to an nope, that wasn't it. I'm gonna say integer, and I'm gonna pass to it as a function character, I'll put a semicolon, and here, okay, this is the first one is, see, like, let's put here, see, like, and here I'll put functional notation. Remember, anything between two double quotes will print as is. The compiler won't bother to read it even. It's saving time. It's not gonna look at it. So I have this. Let's put those back here so my code stays good. So now this is good. Now what if I want to print it in hexadecimal? Here's what we do. C out hex, and I wanna use the, what was it, set? Is it set? Bitset. No, that was the bitset was for, I think, and I think this I print it as hexa, and I'll use the integer one, but I print it as hexa. Let's try this. I want to try this. Why? I've never tried it before, but end line, and I want to do a C out hex. This is how I usually do it. I'll say integer as C casting, and I'll do, let's do X, and here I'll do end line, and here I can say hexa value, meaning hexa decimal, let's say the hexadecimal value of character what is it? Is it CH, which is G? Okay, that's good. I'll know the hexadecimal value, the hexadecimal of character CH, and let's put equals this, and I need to add all of this, control copy here, but why did it do that? Why did it take more space? I can make it less space here, and I can make a space here and here, and it still didn't move, and I can do, come on, okay, now I want to do it as octal also. an octal. I'm gonna let's run this and then I'll see, so I'll know which one we're gonna use. I'm gonna use mainly to this one, the second one, but if that one works, the first one, it's a good way to use it. So what did we name it? Character casting. So I'll do G++ character casting, and if you type tab, let's okay, expected comma before hexa. So okay, what I think it needs here, no, it doesn't need, I need this before hexa. I thought sometimes it does, like end line, it has to be on a separate line. You can't put anything after end line. I thought that was the problem. Here's the character ch casted select to an integer equals 71. The character c casted, same thing, and g equals 47. This is the hexadecimal value, and this is the decimal value. I should have wrote an h beside it indicating it's a hexadecimal, but that's good. How to make sure? I think I had here on my desktop a hexadecimal converter to decimal to hexadecimal. (71) and 47. Let's try them. How can I get 71? 71, I have a 1, 0, and 7. So it's gonna be, this is my number in binary. Hexadecimal we group into 4s. So I'll have here what? 0, 1, 1, 1. And here I'll have 0, 0, oh sorry, 0. I took those 0, 0, 1, 0. And if you can see, this is 4 and this is 7, 4, 2, 1. So that's right, that gave me the right number. Now I can cast it to octal just by copying this. Let's copy this, and I can even print it as binary, and we'll show you all of this. Let me make it look better, guys. Sorry, I'm gonna spread it a little bit here. Okay. I don't know, I don't feel comfortable if my code doesn't look neat. So octal, I have to change the number here and say octal, and let's oct, and I want to type oct here, and same thing here. I don't honestly, I don't need this. I don't want it. I want to just try it once, because I'm gonna try the binary. The binary we're gonna need to it for it to use a library, and we're gonna use the include. Let's see if I remember it. Include, and if you forget it, don't worry. Just go Google it. I'll use the bitset library. And what we'll do here is, here I'll do, there's the bit set, and here it will tell me how many binary numbers I'm gonna print, and what do I want as a binary. Where should I save my binary? My character is okay. X, let's say I'm gonna print X and Y again. I use okay here, and I'll say character. I'm gonna do the same thing, bit set 16, and I'm gonna do it Y, and I'm gonna do character, which is G. This is gonna take it as 16 bit, and here what we do is see out and let's just type binary value. Equals, I'm gonna print X, and here I'll do end line, and I'll do same thing for this, see out binary value of G equals, and that's gonna be in 2 bytes, so you can write 2 bytes, or let's put it here 2 bytes just to show the differences. And line to X, I don't save, and let's do this. Compile, no such file or bit include bitset. Why there's no library? Shouldn't make a difference. I don't think so. Or even more. 8. What is this? Oh, took the library, but now conflicting declaration. std bitset 8 ul x bitset 8. I should pass the character, I think. Did I declare it again as X? Okay, let's say it wants other values, A, B, but I haven't declared them. Let's see if that works. It didn't like having the X. Because it was previously declared. Let's see if this gonna work. No, bitset X. I didn't save because the kept gave me that's how anyway. It gave me the X. Okay, now it's working, and here's my beautiful code. Stay. Here the C-like is 71, character casted, which is G, is 71, and C-like casting, this one where I had it here, functional notation casting is here. It gave me 71. The hexadecimal values are 47 of character G. The octal value is 107, and Yep, that's right, because we take octa, we group into 3 bits each. And binary value, if we group into 3 bits, look at this. The first 3 are what? 7. Those 3 are 0. And this is 1. That's how I knew it's right, 107. And this is in 2 bytes. Printed it in 2 bytes. This looks awesome. Let's see what we have left. Oh, both lectures ended up to be really long. I wasn't expecting that, but that's good for you guys. Let's see, run previous program, online data, type rules, type casting, type implicit program casting into float, and program on oversized variables. And let's leave this no, not this. I don't want this. I want to save it. Let's leave the oversized variable and bool for lecture 4, and I'll add it in an hour or so. Let me just take a break. Thank you guys.